Hello there. So Python is one of the most loved programming languages by developers, data scientists, and even hackers because of its versatility, flexibility, and object-oriented features. And trust me, Python is very easy to learn because it has a clean syntax, meaning that if you are a complete beginner in programming and would like to start easy, this is the go-to language. You won't find any other language which is easier. I first started learning Python about a year and a half ago, motivated by the programming craze that is going on. At first, I wondered who said that this Python language is easy. It's like learning Greek. However, after countless months of slaving away trying to understand what Python is all about, here I am making this course telling you what you need to know and learn in order to master Python. You can think of this course as me trying to teach you how to walk, after which you could learn how to run and jump by yourself. But in order to run and jump, you would first need to know how to walk. And that's what I strive to achieve in this course, teaching you the very basics of Python, the ABCs basically, so that you can understand words, sentences, paragraphs, essays, and so on later on. I'm very excited, and I hope that you are very excited for this too. In this lecture, I would go through the installation process of Jupyter Notebook and explain the course overview. In order to start coding, you will need an IDE, also known as Integrated Development Environment. It is a place where you can write code. Don't get me wrong, even without an IDE, you can write code like using the command prompt or text editor. So, this is my command prompt, and to write Python code, for example, using my command prompt, all I need to do is to type Python and then print hello. You don't have to know what this print function does yet. I'll explain it later, but this is so you can see that a command prompt works in using Python code. Okay, let's move back to the slides. So as you can see, even though a command prompt can write Python code, yet it is not recommended. An IDE has many advantages that a command prompt doesn't. The main one being able to debug your code. As you code more and more, you realize that your code will have a lot of errors. Trust me on this one. And it is essential to have a proper method and tool to debug errors. In this course, I'll be using Jupyter Notebook from the Anaconda distribution. If you have another favorite IDE to use, feel free to use. You could also check out other IDEs such as Spider, Atom, and PyCharm. I use Jupyter Notebook mainly as a personal preference. Now, let's go through the installation process of Jupyter Notebook. Okay, this is my Google homepage. And firstly, what I need to do to download Jupyter Notebook is to find the Anaconda distribution first. So Jupyter Notebook is part of the Anaconda distribution. So all I gotta do is type Anaconda distribution. I'm going to click individual edition Anaconda, the first link that comes out of Google search link, and I'm going to scroll down and find download. So Anaconda distribution is open source. That means it is completely free. So I'm going to click download. Anaconda installers. I'm using Windows, so I'm going to click the 64-bit graphical installer for Windows. Most of the computers will be using 64-bit. Some will be using 32-bit. But I recommend if you've got a computer within the past 5 years, just click 64-bit. If you're using Mac OS, you could click this. If you're using Linux, you will click this link here. So I'm going to click 64-bit graphical installer. It is downloading. So I will skip until the download has ended. Okay, now that Anaconda has finished downloading, I will click this executable file. Then I will click next. You just click agree, next, and then next, 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 and so on. You won't get this because I've already downloaded this Anaconda 3, so that's why there's this warning. You click next and then you will install it. So that's all for downloading Anaconda. Okay, so after you have installed Anaconda, all you gotta do is to click here, Anaconda prompt. So open up the Anaconda prompt. Make sure it's the Anaconda prompt and not the command prompt or Anaconda navigator or anything. Click on the Anaconda prompt, and this window will open here. After which, to open Jupyter Notebook, all you have to do is to type Jupyter Notebook, and this is your Jupyter Notebook. So by typing Jupyter Notebook, it would open a Jupyter Notebook in a window, and here is your Jupyter Notebook. So that's the process of installing Jupyter Notebook. Now we'll move on to the overall course structure. So the first lecture that we're going through is data types, which is basically numbers and strings. The second lecture, we'll talk about variable assignment, so how to assign, let's say, a long number to a shorter variable, and the print function. In the third lecture, we'll go through data structures. I'll be covering two data structures, lists and dictionaries. Lecture number 4, we'll be covering comparison operators. So is 2 bigger than 3? Or is 3 equals to 3? And how a computer reads this input. In the fifth lecture, we'll go through if, elif, and else statements. In the sixth lecture, that's where things starts to get more complicated and more important. We'll be going through loops, for loops, and while loops. And last lecture, we'll go through functions. Functions is mainly used to break up a larger problem into smaller subproblems. And that's all for this lecture. Hi there. This is the first official lecture we're going to start learning about Python. I am very excited for this, and I hope that you are as well. So in this overall overview, we are here in lecture 1 about data types. And in this lecture, we will be going through two data types, strings and numbers. So what are strings? Strings are basically text, anything that isn't a number. We'll see later on that everything within quotation marks is a string. Numbers, on the other hand, consist of floats and integers. Integers basically means whole numbers with no decimal points, and floats, which you can guess by now, is numbers with decimal points. Let's hop over to Jupyter Notebook to explore strings and numbers in more detail. Okay, so to open Jupyter Notebook, do you remember the steps? So all we're going to do is to go here and type in Anaconda prompt. Anaconda prompt, yes, here it is. Okay, I will zoom in. And then after that, you got to type in Jupyter Notebook. And a browser would open. So this is Jupyter Notebook. I've created a folder specifically for this course. So to open a new notebook, what you need to do is to click New, Python 3. And this is your new notebook that appears here. So first things first, you got to give your notebook a title. I'll just call this Lecture 1. And this box here is known as a cell. So this is a cell, and what a cell does is it runs anything inside this cell. So for example, if I have a string ASD, to run the cell, I have to click Shift and Enter, and it runs the cell and it moves on to the next cell. So why Shift and Enter? Let's see what happens if I click Enter. So if I click Enter, it will just go down, down, down. It won't actually run the cell. Instead, it just allows me to type more things on another line. So if I click Enter again, I could type more things. And if I actually want to run the cell, I could click Shift and Enter. And the output will only give the last item that is run in that particular cell. So now let's move on to look at strings. So strings, as mentioned previously, is anything between quotation marks. You can either use double quotation marks, or single quotation marks. So for example, I type hello. This is a string, so the output here is in single quotation marks, but it doesn't matter. It means the same thing, whether the double or single quotation mark. So I could type it in with single quotation marks as well, ABC, and that's a string as well. And moving on to numbers, 1 is a number. 3.2 is a number, but this is a float, and 1 is an integer. So what can you do with numbers? So numbers allow you to do all numerical operations you can do within a calculator. So if I want to add something, I could do 1 plus 2. And what's the result? As you can guess, it's 3. Um, just note that every time I'm running a cell, I'm clicking Shift and Enter. So just a reminder. You just need to constantly remind yourself, especially when you're new, because this is not something that occurs naturally. So some other operations is 3 multiply 2, 6. So multiply is denoted by this asterisk sign. 3 divided by 2. So divide is denoted by this slash sign, 1.5, and then the others is minus. You could also do power. So power is denoted by this double asterisk sign. So 3 to the power of 2 is 9. There are many more operators, like modulus, floor division, which you could find online. I don't expect you to remember everything, but a lot of things could be found online. So this is slightly harder. So what is this? A number within a string. Do you think this is a string or an integer? Sorry, a string or a number? Take a guess. So if I enter it, it is a string. So that you know, no matter what, anything within 2 quotation marks is a string. Then you might wonder, what if I want to put a quotation mark as a string? How does that work? So for example, if I want to type don't, the word don't, and I want it to be in a string, what do I do? So let's say I use single quotation marks for here and single quotation marks for here. And I click enter. It's an error. So quotation marks in Python is a special character. And as you can see, putting quotation marks within a string won't work. So how do you overcome this? One way is to use double quotation marks and then using that single quotation mark within your string. And there you go. So that's how you do it. So just make sure that your string outer string quotation marks isn't the same like any other quotation marks inside the string. And that's all for this lecture. Thank you. Hello there. In this lecture, we'll be looking at variable assignments and print statements. Variable assignments greatly simplify things. So for example, 6 plus 5 is 11. Instead of calling 11 over and over again, we could just assign it to a variable, x in this case. You might wonder, why is it so hard? What is so hard about calling 11 every time? But just imagine, if you have a long number, a long and large number, it will be very hard to call it every time. Another purpose of variable assignment is for clarity. So for instance, John's height is 1.5 meters. So we assign the height of 1.5 to John. John equals to 1.5 in this case. Jack, on the other hand, is 2 meters tall. So we assign 2 to Jack. If you just look at 1.5 and 2 alone, it has no meaning on its own and is hard to manage. After we assign it, we know that John is 1.5, which means he has a height of 1.5, and Jack is 2. The second content for today is print. So print is a built-in Python function whose purpose is to display. So if you want to see the value of variable, you have to call the print function on the variable in order to see it. Let's hop over to Jupyter Notebook to see some examples. Okay, so here I have my Jupyter Notebook open. So let's start. So earlier in the slides, we see that Jack has a height of 1.5. So how do we do this? So all I have to do is to type Jack. This is the variable, and it's assigned a value of 1.5. So the equals to sign here assigns the value of Jack to 1.5. So I will shift enter to run the cell. So now Jack has a value of 1.5. Next, John has a value of 2. So his height is 2 meters. Then I'll run the cell. Note that you don't see any output. So unlike ABC, you see an output here. When you assign a variable, you don't see an output. So now, if let's say I don't know what Jack and John is, so how do I know what is Jack and John? So in order to know what value this Jack and John has, I have to call the print statement. Print Jack. And there, Jack has a value of 1.5. So in Jupyter Notebook, even without the print statement, it would output the value for you in this case. However, for other IDEs, some of them would require the print statement to see the result, while others don't. So it's always good to just write print. Note that this variable here, this assigned variable is case sensitive. So for example, if I typed print John, not capital J, note the difference. There's an error because John is not defined. Therefore, it's case sensitive. You need to type exactly the same as what you've assigned a variable as. So a capital J in this case. And there you go. John has a value of 2. So from the previous lecture, we learned strings and numbers. If you still recall, Jack and John here, these assigned variables, are numbers. And operations can be done on these numbers. So just to reiterate, what some of the operations that can be done on numbers is like 1 plus 2, you should get 3. 3 times 3, you should get 9. So what do you think is the result of Jack plus John? Note that this variable assigned are both numbers. So looking at it, I'll get a value of 3.5. And that's right. Okay, so I would like to assign sum of height to be the sum of height of both Jack and John. And that's how I do it. So variable assignment and addition of numbers. A good thing to note is that this variable name, even though it's long, it's good to write a full name instead of something short and not clear, because this gives clarity and it prevents error in the long run. So avoid using variable names like, for example, A, which has no inherent meaning to it. So A equals to Jack plus John. The problem with using A is that when someone reads your code, they will have no idea what A is. Whereas sum of height, I know that this variable is the sum of height of both Jack and John. So name your variables well. Thank you.
In today's lecture, we'll be covering data structures. If you find the past 2 lectures quite mundane, easy, or dull, this is where things start to get more interesting. Data structures is one of the most important topics in Python. It is one of the basic building blocks where every other thing is built upon. In today's lecture, we'll be covering 2 main data structures, lists and dictionaries. Other data structures such as tuple, linked lists, stack and queues, and trees won't be covered in this course. However, why I say that lists and dictionaries are the most important, because other data structures such as linked lists, stacks and queues, and trees are actually built based upon lists and dictionaries. So let's move to lists. So list is an ordered element of value. So you could imagine a shopping list where you list down what you want to buy. For example, apples, oranges, and grapes, and this is the syntax of a list. It's denoted by square brackets at each side with the items separated by a comma for each item in the list. And the list index starts with 0. Well, let's hop over to Jupyter Notebook to see more about list. Here I am in my Jupyter Notebook. In regards to lists, there's two main things I would like you to take away. The first is the append method for a list. So the append method allows you to add an item to an end of the list. Note, the list must exist for you to add anything to it. So the list must exist before you could add anything to it. So let's see what's a list. So for example, I got a list called shopping list. And list is denoted by these square brackets here. So this is an empty list. And now, sorry, shopping list, there's a T there. And now if I write shopping list, and I click enter, I could see that it's an empty list. So if I want to add something to a list, I use the append method. So that's the first thing I want you to take away. So append. So to add something, I'll put shopping list dot append apples. Note, I'm adding this string apples to this shopping list. Click enter. So now if I want to see what's in my shopping list, I'll click print shop. So you could click a tab to autocomplete it fast. So click it by clicking a tab button, it would autocomplete shopping list fast. So apples, now my list has apples in it. Let's say I want to add more items to my list. So shopping list dot append oranges and grapes. So I'm missing a comma here. It doesn't work. This is because append only allows you to take in one argument. It doesn't allow you to append two arguments. So if I want to append oranges and grapes, I will have to append it one by one. So oranges is added. I could copy and I will add grapes as well. So now my shopping list has 3 items, as you can see denoted here: apples, oranges and grapes. Do take note that, let's say I got another list called shopping list 2, which is not here, and I want to append something to shopping list 2. Shopping list 2 dot append on append, let's say a pencil. Note that this will result in an error. Why? This is because in order to append something to a list, I need to have the list there in the first place. So I need to create a list with shopping 2 before I can append anything to shopping list 2. So now I'll append. And shopping list 2 would have 2 items. The second thing that I'd like you to take away is list indexing. List indexing. So the element of each sequence is assigned a number. So what do I mean by this? So I'm going to bring out shopping list again. Shopping list. So each element in this shopping list, there's 3 elements here, is assigned a number, and the first index is always 0. So in this case, 0 would correspond to apple, 1 would correspond to orange, and 2 will correspond to grapes. So that's 3 items in the list, but for list data structures in Python, the list indexing always starts with 0. So this could be a bit confusing for beginners to understand. So this, again, I repeat myself, is item number 0, oranges is item number 1, and grapes is item number 2. So what is so powerful about indexing? So indexing allows you to access values in the list at a particular index. So what do I mean by that? So for example, I want to access the first value in the list, which is apples at index 0. So how do I get the first item in the list? So I will click shopping list, square brackets, 0. So this allows me to obtain the first items in the list? Apples. So what if I replace 0 by 1, the second item in the list? What do you think I will get? Oranges. That's right. And 2, grapes. So what do you think would happen if I put 3, index number 3, which corresponds to the fourth item in the list? Note that there isn't 4 items in the list, but only 3. So what do you think would happen? If you haven't guessed it, this will result in an error, list index out of range, because there isn't an item there. So list indexing also allows you to do list slicing. So list slicing allows you to obtain 1 or more items from the list. So currently, by clicking shopping list 0, you can only obtain 1 item from the list. What if I want to obtain apples and oranges? What do I do? So if you could remember, apples correspond to index 0, oranges correspond to index 1, and grapes correspond to index 2. So in order to obtain apples and oranges, I will use this semicolon feature. And 2. So this means that I would like to take everything out of the shopping list, starting at this index 0 to this index 2. So anything within 0 and 2 is taken in the list. And here you go, oranges and apples. Note that it does not include the number 2, but only 0 and 1. So 0 up to 2. Okay, let's just make this a longer list. So shopping list dot append, I'm going to add 2 more fruits. Watermelon, that's 1. I'm going to append another fruit there. I'm going to append a durian there. Okay, so now shopping list has 5 items. And let's say I want to take oranges to durian, but not apples. So how do I do this? Pause the video if you try it out by yourself first. So if you have tried out, the answer is from index 1, starting at oranges, all the way to the end. So all the way to the end, if I put 0, 1, 2, 3, 4. If I put 4, it won't include durian. Because as you have seen in this example, if I put 2 here, it won't include grapes. So if I want to include durian, I'll just leave it blank there. That means it will take from item 1 all the way to the end. So it includes durian. And if you might have guessed as well, if I put a semicolon first and then 4, it will take all the items before here all the way up to number 4. And that would give me apples, oranges, grapes, and watermelon. So this is list slicing using index. There's one more thing that I would like you to take away, and those are 2 methods to remove items from the list. So the first method is the .pop method. This is a built-in Python method. And the second method is .remove. So .remove and .pop. These are both methods to remove items from a list. So let me just increase the number of cells. So let me show you an example. So the difference between pop and remove is that pop takes in an index and remove takes in an item. Let me show you what I mean. So just to show you again, this is my shopping list. I'll write it here so it becomes more clear. Shopping list. This is my shopping list. I have 5 items here. And let's say I want to remove apples. How do I do this? So firstly, by using the pop method, shopping list dot pop. So pop takes in an index value. So if I want to remove apples, apples is at index 0. So I enter 0. If you notice, there's a typo here. Shopping list dot pop 0. So this is removed from shopping list. So if I type in shopping list again, there's no more apples, oranges has become the new first item on the list. By default, pop will take away the last item of the list. So if I just pop it, durian will pop out from the list. Another way to pop up durian would be to put in index 3. This also pop up durian, but just to show you that pop by default take out the last item from the list. So durian. So now my shopping list only have 3 items. I'll just bring up the shopping list again. Shopping list, it has 3 items. So now I'm going to show you the remove method. Shopping list dot remove, and let's say I would like to remove grapes. So I'm going to put in grapes here, and voila, grapes is removed from the list. If you put in something that isn't on the list using the remove method, like water, as you could expect, you'll get an error because this isn't in the list. So to recap what we have covered so far, firstly, we have covered the append method. You have to this method allows you to append something to an existing list. Note, an existing list. Next, we covered list indexing. List indexing. So the first element of the list starts with the index 0, then 1 and 2. List indexing allows you to do list slicing, which allows you to take more than one objects, whereas list indexing only allows you to take one object at a time. So for example, shopping list 0 will give you oranges, and shopping list 0 to 2 will give you all items there. And lastly, the pop method by default pops out the last item of the list. You could put in the index there to pop out the specific item you wish to remove. And the remove method takes in the item which you want to remove from the list. So these are the 4 things that I like you take away: append, indexing, pop, remove. And that concludes our list. Next, we'll move on to dictionary. So this is our second data type, dictionaries. So dictionaries by default has a key and a value. In a dictionary, you search up a word and you get its definition. The word is the key and the definition is value. So this, in a normal dictionary, you search up a word and you gets its definition. The key, this dictionary is denoted by these curly brackets, where you put in a key, a semicolon, and then you enter in its values. So for example, this dictionary name is called dictionary, and the key here is apples, which has a value of $2. Then to enter another item in dictionary, like a list, I'll put a comma there to separate out the items. And the oranges is another key, and 3 is its value pair. To search something up in a dictionary, all I have to do is to enter its key. So I put the dictionary name there, square brackets, and the key of the item that I will search out. And as a result, I will get 2. So again, let's hop over to our Jupyter notebook again to see some examples. Okay, here I am at my Jupyter notebook. So in today's dictionary, I'll just call it food. And as like I mentioned just now, dictionary is denoted by this curly bracket. So this represents a dictionary. So let's enter something in our dictionary. So before I enter anything in dictionary, I just want to recap. So a dictionary takes in a key. So this is a key and a value. So food, I like fruits, so I'll put apples, and I'll put a price of 2. Note that this is a string and this is a number. I'll add in another price, another item pair. So grapes has a price of $3. And there we have 2 items in our dictionary, apples and grapes. So if I print out my dictionary, I get apples and grapes. To add something into a dictionary, this is what I need to do. So if I want to add something in the dictionary in Python, there's the append method. In dictionaries, you add it using another way. So if I want to add, let's say, oranges in my dictionary, I have to type food, oranges. This is the key, and this is my dictionary name, equals to, and this is the value, 4. So now my dictionary has 3 items. So now that we have seen how to add items in the dictionary, what if I want to find out how much my grapes cost? So instead of printing out every item in the dictionary to see how much my grapes cost, to look up an item, it's the same syntax as adding an item. All I have to do is type the name of the dictionary and the item that I want to search up. So note that this grapes item is already in a dictionary, and if I click enter, I'll get the value for this key pair. Unlike list, dictionary allows you to look up item much faster and easier. So to conclude, lists and dictionaries are two of the most useful data types in Python, which can be used to build up more complex data types such as stacks, queues, and trees. You use dictionaries when you want to look up for something fast and have a set of unique keys to map to your values. And you use lists when you have an ordered collection of items. Oh, before I forget, note that if an item already exists in your dictionary, apples, and you want to add another item, also with the name apples, you can't because the item already exists in your dictionary. Doing this here, what you do instead is you change the value of apples. So each dictionary has a unique key. So there are no repeated keys, whereas in the list, you could have more than one of the same items. So that's a special feature about dictionary. However, in dictionary, you can have non-unique values here. So for example, apples and grapes can have the same price. You just cannot have the same key. Okay, let's move on to an example. So this would be a list exercise. Because this is a long lecture, I thought it would be good to do an exercise. So, Mom asked me to buy apples and oranges. Dad then asked me to buy shampoo. Mom changes her mind and no longer wants to buy apples. Okay, think of this problem and try to come up with a final shopping list. If you need more time to do it, please feel free to pause the video. I'm going to start the problem. Okay, so I'm going to create new list, and it says that Mom asked me to buy 2 items, apples and oranges. So I'm going to create a list with 2 items. Dad then asked me to buy shampoo. So to account for what dads want to buy, I'm going to append shampoo to my list. Append shampoo. And finally, Mom changes her mind and no longer wants apples. So what do? I remove apples from the list. To do that, there's 2 things I could do. I could either pop index 0, or I could remove apples. I'm going to do the latter. Dot remove apples. Okay, so now let's see what I have on my list. So this is my final shopping list with oranges and shampoo only. That's all for this lecture, and I thank you once again. Hi there. In this lecture, we're looking at comparison operators and booleans. First, we'll look at boolean. A boolean basically has only 2 values, true and false. Comparison operators are operators which allow you to check whether something is true or false. So comparator operators and booleans on its own isn't much, but becomes very useful when used together with if statements and loops. So let's treat this as a lecture, as a prerequisite for the if and loops lecture. Let's hop over to our Jupyter notebook. So here I am on Jupyter Notebook. Firstly, we would look at booleans. So if you haven't known already, this hash sign here is a comment function, so it doesn't actually do anything. It's just a comment for you to comment. So booleans, true. Sorry, no caps, true. This is a boolean, and false. This is a boolean as well. So make sure that you don't type like small letter. It doesn't work. It has to be, starts with the capital letter, and then the rest are small. So true with a capital T and false with a capital F. So let's move on now to comparison operators. So there are four main comparison operators that we've seen previously: the less than sign, the greater than sign. This double equals to sign, it means equals to, and the not equals to. Obviously, there are many more comparison operators, but these are the basic few. So let's move on. So 2 is less than 3. So this is a comparison operator with less than, and I'm checking whether 2 is less than 3 in this case. And this would result in true because 2 is actually less than 3. How about 4 is less than 3? Again, using the less than comparison operator. This results in a false statement. So I'm going to check if, so besides numbers, I could check whether I could check on strings as well. So strings A equals to B. So this equals to means equals to, and A is not equals to B. How about B equals to B? And this is true. So this is equals to. So now I'm going to check the not equals to. A not equals to B, true. B not equals to B, false. You could also mix operators, so you can mix the less than and equals to. So for example, 3 less than equals to 5. It is true. 3 less than equals to 3. This will result in true as well. But it's 3 less than 3. False. So the same thing could be done with the greater than equals to, and so on. So that's all for this lecture. Thank you. Hi there. In this lecture, we'll be looking at if, elif, and else statements. If statement is one of the most frequently used statements in Python. It allows you to check whether a condition is true before executing something. Think of if statement as this. There is a bouncer outside a nightclub. If your age is above 18 years old, you're allowed to enter. Else, if your age isn't above 18 years old, you're not allowed to enter. You can also use if statements. You can also use, elif statements and else statements together with if statements. Let's hop over to Jupyter Notebook to see some examples. Okay, so I will start with the bouncer example at a nightclub. So your age is some age. I'll give you an age of 12. If your age is less than 18, it's greater than 18, print you can enter. Note that there's an indentation here. This shows that you are within that if statement, and also note that there's a semicolon here. So it's a if condition and then followed by a semicolon. That is an if statement. So if age is above 18, print you can enter. Obviously you get no output because this if statement condition is not satisfied. So let's say I change my age to 19. You can enter. So besides if statement, I'm going to add an else statement. So like we mentioned previously, an else statement could be used together with an if statement. Else. So an else statement runs when an if statement is not satisfied. So in this case, if your age is less than 18, less or equals to 18, your else statement will run. So print you cannot enter. So let me change my age to 13. You cannot enter. So what happens if I put my age as 18? What do you think the result would be? So in this case, the result would be you cannot enter, because if age is above 18, then you can enter. But 18 is not greater than 18. Because 18 is exactly 18, therefore an else statement runs instead. So if I change this to greater than and equals to 18, it would be you can enter. Okay, let's look at another example. So I'm just going to comment this out. Okay. So in this example, again, you have an age. I'll just put a value there. And I'm going to say if your age is between 7, so your age is greater than 7 and less than 12, I'm going to print I am in primary school. So besides an if statement, I also can put in an elif statement. An elif statement is another if statement if this if statement is not satisfied. So you could think of this like this. First, I will check whether this condition is true. If it isn't true, I will check whether this condition is true. If this condition in the elif statement isn't true as well, then I'll move on to else. So let me just put in an else statement condition. So secondary school, else print I am in college. So there are 3 checks to be done here. The if, whether you are between the age of 7 and 12. Elif, whether you are between the age of, can't be 12, 13 and 19. And if that isn't the case, it will check whether, it will just print I am in college. So at age of 5, I am in college. That's something weird. So it is strange because 5 isn't within this statement, and it isn't within this statement as well, therefore it prints I am in college. But this won't work. Okay, so in order to account for 5, I'm going to add in another statement. So elif here, and I'm going to add if age less than 6, print I am still a baby. So I'm going to run this again, and I am still a baby, because it will check whether this is satisfied, and this is satisfied because 5 is less than 6, therefore it prints I am still a baby. So I'm going to change the age to 15. Where do you think this would be? If you say secondary school, yes, you're right, because 15, firstly it will check this statement. If this statement fails, it will check the next elif statement. If this elif statement again is not satisfied, it will check this elif statement, and this elif statement satisfied, therefore it prints secondary school. Okay, moving on to another example. This is a slightly more complicated example. We'll be using lists together with an if statement. So I'm going to create a list called my shopping list. You should be familiar with lists. If you need to recap, you could just watch the previous lecture on lists again. So my shopping list contains 3 items. I'm just going to put 3 items here. My shopping list has 3 items. And so this is my shopping list. It has 3 items. So I'm going to use an if statement. If orange in my shopping list print buy it. So this is a check on whether my item is in my list. So in this case, if my orange is in the list, it would print buy it. So buy it. So note that this is another thing you haven't seen before, this in. So it's used in together with an if statement to check whether it is in a list or a dictionary. So let's put another fruit here. Let's put watermelon. If watermelon is in my shopping list, print buy it. And it isn't in my shopping list, so this condition is not satisfied and it wouldn't print it. So you could use an if statement alone, even without else statement. But if you want to put an else statement inside as well, you could do it as well. Note, something important to note is the indentation. The if, elif, and else statement has to be on the same indent. Print don't buy it. And don't buy it, because if watermelon is in shopping list, print buy it. But if it isn't, print don't buy it. That's why you get a don't buy it here. That's all for this lecture. In the next lecture, we'll be looking at loops, and that's a very interesting lecture in my opinion. Thank you. Hi there. In today's lecture, we'll be looking at loops. There's two main loops that we'll look at. First is the while loop, and second is the for loop. Let's not waste time and jump over to the Jupyter Notebook. Okay, so Python has two primitive loops command, the while loop and the for loop. With the while loop, we can execute a set of statements as long as the condition is true. So for example, first I'll put a counter called I here, and a while loop is while followed by a condition. I'll just capitalize it, and followed by again a semicolon, enter. Note again there's an indentation to signify that we are within the while loop. So the condition here would be, I'll just put it I less than 6, and I'm going to print I, and most importantly I got to add 1 to I. So there's two ways you could increase I by 1. So this is I plus equals to 1 is the same thing as I equals to I plus 1. So both have the same meaning, but plus equals to looks neater. So I'm going to enter this, and it prints 1, 2, 3, 4, 5. So what this does is that I equals to 1. This while loop checks whether 1 is less than 6. If it is, it would carry out the function inside the while loop, which is printing I and adding 1 to I. So after adding 1 to I becomes 2. It will check again whether the condition is true. If it's true, it will run again. Therefore, 2 is printed, 3 is printed, 4 is printed. And when it's 5 is still less than 6, so the condition is still satisfied. It would print 5, and then it will add 1 to 5, which is 6. When it reaches 6, this while loop condition is not satisfied any longer, and therefore the loop stops. Therefore you see just 1, 2, 3, 4, 5. Note something very important is that this increment of I here, I equals to I plus 1, is necessary. If this is missing, the loop will just run forever and the loop won't stop, because I will keep, if this is missing, I will keep being 1, and the loop and this condition will always be satisfied, so the loop will just keep continuing. Obviously I don't want that to happen, so I'm not going to try that. Okay, so let's look for for loop lengths. So a for loop is used for iterating over a sequence that's either a list, a string, tuple, dictionary, or set. With the for loop, we can execute a set of statements once for each item in a list, again, tuple, set, etc. So let's just jump over to some examples. Okay, so firstly, let's say I got 3 types of fruits. Again, this is a list. If you can't remember what the list is, please go back and recap. So there's 3 items in this list. And now I'm going to use a for loop to iterate over each item in the list. So this I here is it's like a counter. It acts as I, so it will go through every item on the list. You could replace I with anything you want. So I could just say item, it will work the same. So I'm going to print item. So what it does is that for each item in fruits, it would go through the list once. So it will go through apples, first item, it will print out apples, and then after this first loop is ended, it will go through again to run it again to check whether there's any more items in the fruits, and it does. So it will go oranges, it will run again grapes, and then after that there's no items. That's when it stops. So that's the most simple for loop, iterating through a list. So besides lists, even strings are iterable. So I could say for I in apples, print I. So it works the same way as a list, that it will just keep going through every alphabet in this word here. So A, P, P, L, E, S. So obviously you could do this for dictionaries, tuples, and sets as well. A function that I would like to introduce to you now is the range function. So a range function prints out a list of values within that range. So there's a start and there's a stop. So for example, for I in range 5, print I. So range value is between 0 to 4, and it will print 0, 1, 2, 3, 4. Note again, the last number here within the range is not included. So I could also change this to 2 and 5, and it will print all the values between 2 and 5. 5 not including 5. So 2, 3, and 4. So this is the for loop. Okay, next. In the next lecture, we'll look at functions. It's the last main chunk that we'll be looking at. Thank you, and see you in the next lecture. Hi there. This is the last content lecture, and we'll be looking at functions. So a function is important in breaking down a bigger problem into simpler problems. A function helps to simplify the problem. So for example, in a company, there are many departments, and each department acts like a function. So there's a sales, like in a company A called ABC, there's a sales department, marketing department, and programming department. Each of those departments does a different task. However, it feeds back into a bigger picture, which is the company, and that's what a function is supposed to do as well. So let's hop over the Jupyter Notebook to see some basic function syntax. Okay, so something to note is that a function is a block of code which only runs when it is called. So if it's not called, a function would not run. So you can pass data, known as parameters, into a function, and a function can return a data as a result. To create a function, we use def. So def followed by a keyword and followed by def, which is a keyword, followed by a function name, and then followed by a semicolon. So this function name is good to give a function a name that represents what the function does. However, for example, I'm just going to name a function called my function. It has no functional purpose. It's just to print hello. So when I run it, nothing will happen. Sorry, define my function. There should be a brackets here. That's why it's coming on an error. Print hello. So when I run the function, nothing would happen. This is because a function will not run unless I call the function itself. So I have to call the function here, my function name, followed by this open and close brackets, in order for the function to run. So this is calling a function. A function also can accept arguments. So within this bracket, I could put in arguments. So define multiplier. I'm going to create a function name called multiplier, and it takes in two arguments, x and y. And this function returns the multiplications of x and y. So again, nothing happens when I click enter because I got to call the function in order for it to run. So to run the function, I will click multiplier and I'm going to multiply two numbers. So what this does is it takes the x multiplied by the y, and as a result you would get 20. So something that you usually use together with function is the return call. So I'm going to copy in the same function, and instead of print I'm going to put return x and y, x times y. So this function returns this output. So by default, if I click again multiplier 4 times 5, it would show 20 because this output is returned. So typically if you want, we will return a value so that this value could be used somewhere else. So that's the purpose of a function. So just to recap, we look how to call a function. Firstly, df followed by a function name and then brackets. So within the brackets you could enter in arguments. It's really up to you how many arguments you want to, but obviously keep the arguments not too many because you might confuse yourself. And then after that, there's this return statement as well, which returns output of the function. So that's all for this lecture, and thank you. And in the next lecture, we'll be looking at some exercises which includes all the topics. Hi there. This is going to be our final lecture. So in this lecture, we'll be looking at an overall exercise that covers most of the topics discussed in the previous lectures. We are going to create a function that takes in a list of exam grades, maths, physics, English, biology, and art, and outputs the average. If the average is above 50, we're going to return pass. If not, we're going to return fail. So let's hop over to Jupyter Notebook. Okay, here I am. So we are going to create a function that takes in a list. So firstly, I'm going to create a function that is exam results. That is called exam results. And I'm going to take in a list. So this is just a variable. Okay. So if we take in the list, I'm going to use a for loop to pass through each of the element in the list. So let's say, for example, exam results. I'm going to key in 5 different grades, which represent for my 5 different subjects. Okay, then I'm going to pass through the list, this list. So I'm going to type for result in list. Sorry, I shouldn't enter it yet. So firstly, I'm going to create a placeholder which holds my result. And for result in list, I'm going to add my, this shouldn't be, okay. I'm going to add my result to this results placeholder. I should have chosen a better name. I'm going to rename it as results placeholder. So this is clearer. So my results placeholder will add the result for each item in this list. And then after it has done that, to get the average, I'm going to divide it by the total number of items in the list. So results placeholder equals to results placeholder divided by length list. Do note that if I want to use this list, I have to put lists here. I'm going to call it list. I can't call it exam results. So note that if I want to use the variable, I'm going to call it the variable here. Okay, just checking my indentation whether it's correct. So this should be outside the for loop, it shouldn't be inside the for loop, and it should be inside the function. Therefore, it's indented correctly. Then I'm going to do an if statement to check whether I pass or fail. So if results placeholder holder is greater than 50, I'm going to return that I pass. If I got below or 50, below or equals to 50, I'm going to just return fail. So this is my function. I'm just going to put this results placeholder within the function because it's pointless, it's outside the function. And I'm going to run it. So there are no errors in the function. Again, the function is not run yet because I have to call the function in order to run it. So I'm going to call the function and I'm going to enter in exam results as the variable, as the list variable, and pass. So what this does is that firstly I'm going to create a variable called results placeholder, which is equals to 0 initially, nothing inside the placeholder. Just treat this as a holder for later on. Then I'm going to, for result in list, for each item in this exam results, I'm going to go through it and I'm going to add it to my results placeholder. So 0 plus 50, then I'll run the for loop again, plus 80, plus 40, plus 60, plus 55. And then after that, I will take this result from this for loop and I will divide it by the total length of this list, which is 5. With that, I will get a number. And then if this number is greater than 50, I'll receive a pass. If it's more than 50, I'll receive a fail. And looks like we pass. So just to double check, I'm just going to add this 5 numbers together to show what the for loop is doing. So this is what the for loop does. It adds up all this number and I get a result of 285. And after 285, I divide it by the length of list, which is divided by 5. And I get 57, which is greater than 50. Therefore, I got the pass. So that's all for this exercise. If you can do this exercise, congrats, you did have a good grasp of the basics. Thank you.